Welcome to the Deep Dive. You're here because you want to get smart, fast, on interesting topics, right? Without getting totally overwhelmed.
Yeah, cut through the noise.
Exactly. So today, we're doing just that. We're diving deep into something pretty fundamental to learning. How well we actually know if we're solving problems correctly.
Mm-hmm. That moment after you finish something tough.
Yeah, like a puzzle, or maybe a work task. How sure are you that you nailed it? That ability, judging your own accuracy, it's called monitoring accuracy.
And it's surprisingly critical for effective learning.
Yeah.
It really boils down to knowing when to keep practicing or, when to move on.
If you're off, you waste time.
Yeah,
Either spinning your wheels on stuff you already know or jumping ahead too soon.
exactly. So for you listening, if you want to learn efficiently, getting better at the self-monitoring is, well, it's super valuable.
Okay, so our mission today, unpack some really fresh research, hot off the press, basically.
August 2024, Educational Psychology Review.
Right. It's a meta-analysis, pulling together results from 35 different studies, all looking at how to boost that monitoring accuracy for problem solving.
And a meta-analysis is great because it gives us that bigger picture. What does the evidence consistently show across different studies? It helps find what really works.
Okay, let's get right to it then. The big overarching finding, well, interventions do seem to help, generally.
Yeah, there's a small positive effect overall. The study found a Hedges G of 0.25.
Now, small positive effect might sound a bit, but it means there's something there, a consistent nudge. But here's the kicker, and where it gets really useful for you.
The type of intervention matters a lot.
Right, that overall average number, it hides some really big differences depending on what they actually did in those studies.
Exactly. So the researchers grouped the interventions, which is super helpful. That's where we find the actionable stuff.
Okay, so first up, interventions targeting the learning task itself, how you engage with the problem.
Within that, they had a few categories. First, whole task interventions.
Whole task, what's the core idea there?
It's basically about helping you grasp the entire problem, the whole picture, and where your knowledge fits in.
Okay.
Think about maybe making a concept map after reading something complex, or jotting down keywords, getting that holistic view of the problem space.
That makes sense. Building a framework so you can see the gaps. Okay, second type under learning task.
Metacognitive knowledge interventions.
Sounds closer to that self-awareness thing.
Precisely. It encourages you to think about your thinking, like during and after solving the problem.
So not just getting the answer.
Right. Reflecting on the steps you took, why you chose them, how confident you felt during the process, explaining your reasoning out loud maybe, or answering prompts about your approach.
Making that internal chatter more focused and deliberate.
Gotcha. And the last one in this group?
Procedural knowledge interventions.
Ah, the nuts and bolts.
Exactly. The specific steps, the content needed. Like the algorithm for a specific math problem, making sure you know and can execute those steps correctly. Okay, so that covers ways to change how we interact with the problem itself. What was the other main category of interventions?
Those that directly targeted the metacognitive judgment, so aimed squarely at improving the self-assessment part.
Directly trying to make us better judges of our own work. Okay, what types fell under that?
They had three main types here. First, timing interventions.
Timing.
Yeah, changing when you're asked to judge your performance, like right after solving versus waiting a bit. Or maybe judging more frequently.
Interesting. You could argue for both delay-giving perspective or immediacy being better because it's fresh.
Right. It's not obvious which way it would go.
What else in this direct judgment category?
Second was external standards.
Okay, that sounds more straightforward.
It is giving you a benchmark, some kind of reference point, could be simple feedback, right or wrong, or even feedback on how accurate your initial confidence judgment was.
Ah, gotcha.
Yeah.
Something solid to compare against. Takes the guesswork out. And the last one?
Monitoring training.
So like teaching people how to monitor.
Yeah, direct instruction, teaching specific strategies for reflecting on your steps, spotting errors, gauging your confidence. Kind of like metacognition, but framed as explicit training on monitoring.
Okay, great overview. We've got interventions focused on the task and interventions focused directly on the judgment itself. So, the million-dollar question, what actually worked best?
This is the key takeaway, really. The meta-analysis showed clear winners, whole task interventions, metacognitive knowledge interventions, and providing external standards. All showed significant improvements.
Wow, okay. So, digging deep into the problem, thinking about how you solved it, and getting some kind of reality check, those are the things to focus on.
That's the core message.
Fantastic. Now, What about the stuff that didn't work so well, or you mentioned even had a negative impact?
Yeah, this was the big surprise, those timing interventions, just changing when people judge themselves. They actually had a small negative impact on accuracy.
Oh, really? Negative? That seems totally counterintuitive. I'd assume giving yourself more time would help.
Me too, initially. But the researchers had some interesting thoughts on why that might be, specifically for problem solving.
Okay.
Well, unlike maybe just recalling a fact, the important clues for judging problem-solving accuracy might be tied really closely to the process itself, the steps, the tricky parts you navigated.
Ah, so if you wait too long.
Those immediate cues might fade. Your memory of the struggle or the insight gets fuzzier, making your judgment less grounded.
Okay, that makes sense for delayed judgments. What about judging more often?
The concern there was that it might just reinforce whatever confidence level you already have, accurate or not. If your internal gauge is already off, checking it more often doesn't fix it.
Right, it just gives you more readings from a faulty instrument. Okay, that's fascinating, but timing. What about the others that didn't show significant positive effects? That was procedural knowledge, mixed interventions, and monitoring training alone.
Exactly. Procedural knowledge, knowing the steps, is vital for solving the problem, obviously. But just focusing on that didn't seem to improve the self-assessment part. The mixed interventions were just too varied to draw clear conclusions, and yeah, surprisingly, monitoring training by itself didn't move the needle significantly.
So just telling someone how to monitor isn't enough on its own.
It seems not. The researchers speculated maybe it needs to be paired with something concrete, like those external standards we talked about.
So you need the training and the benchmark.
Potentially. Without that external reference, how do you know if your improved monitoring skills are actually leading to more accurate judgments? It's like learning navigation theory without a map or compass to check if you're actually on course.
Okay, that makes a lot of sense. We're getting a much clearer picture now of the why behind these results. The meta-analysis connected this to some theories, right? Cue utilization.
Yes, exactly. They suggested that whole task and metacognitive knowledge interventions work because they help you focus on the right cues, your actual understanding, the effectiveness of your strategy. Using better cues leads to better judgments.
Shifting focus from just the answer to the quality of the process.
Precisely. And the success of external standards. That lines up with helping people, maybe especially novices, overcome potentially flawed internal standards.
That whole you don't know what you don't know idea.
Kind of, yeah. External feedback provides that necessary reality check, that calibration.
Right. And they reinforced why timing might be different for problem solving versus, say, memory tasks.
Yeah. For memory, a delay might force retrieval, which is a good cue. But for complex problem solving, the richness of the immediate experience seems more critical for accurate self-judgment.
And monitoring training alone being insufficient. It really highlights needing that feedback loop or deeper task engagement.
It seems so. Plus, they mention working memory load.
Ah, right.
Problem solving is complex. It takes a lot of mental bandwidth. That cognitive load might just wash out the effect of some of the more subtle interventions if your brain is already maxed out just trying to find the solution.
Makes total sense. Okay, so the effectiveness wasn't uniform across the board. There were other factors, moderators, that influenced the results.
Yes, definitely. And these nuances are important. One big one was school level.
Okay.
The interventions were actually least effective for secondary school students compared to both primary school kids and adults.
Really? Least effective for teenagers. You might think they'd be getting better at self-reflection.
You might, but the researchers pointed to something often seen in education research. Motivation tends to dip during adolescence.
Ah.
So the suggestion is maybe lower motivation means less engagement with these kinds of self-monitoring strategies, which blunts their impact. The tool only works if you actually use it and use it well.
That's a crucial point. Engagement is key. What other factors did they look at?
The type of judgment made a difference.
How so?
Interventions work better for retrospective confidence judgments, judging how confident you are after finishing the problem compared to judgments of learning, which is predicting future performance before you try.
Okay, so looking back is easier to get right than predicting the future.
Seems that way. Reflecting on what you just did versus forecasting how you'll do on something new makes intuitive sense, maybe.
Yeah, I think so. Analyzing the past versus predicting the unknown. And the last factor, setting.
Right. Lab studies generally showed bigger effects than classroom studies.
Not surprising, labs are more controlled.
Exactly. But, crucially, the classroom studies still showed positive effects, Maybe smaller, but still there.
So even with the messiness of a real classroom, these strategies can still help. That's encouraging for practical use.
Definitely suggests real-world applicability, even if the effect size is a bit more modest outside the lab.
Okay. And like all good research, they acknowledge limitations. What were the main ones?
Well, 35 studies sounds like a lot, but for a meta-analysis, it's still relatively modest,
Okay.
especially within some categories like timing interventions. There were only a few studies. Makes those conclusions a bit less robust.
Need more research there.
Yeah. And of course, there are always unmeasured factors, contextual things in classrooms or with specific student groups that could be influencing things.
Standard caveats, but important to remember. The real world is complex.
Yeah.
Okay, how do they tie this back to the bigger picture of self-regulated learning, SRL?
Well, accurate monitoring is like foundational for SRL if you know what you know and what you don't.
You can make smarter choices about your learning.
Exactly. When to get help, when to practice more,
Oh.
when you've actually mastered something and can move on. Better monitoring empowers more effective, independent learning. That's the whole goal of SRL.
It all comes back to that efficient, thorough learning we talked about at the start.
Yeah.
You need that accurate self-assessment. Okay, let's try and wrap this up for our listeners. Key takeaways.
Number 1, you can get better at judging your own problem solving. It's not fixed.
Good news.
The best bets seem to be really understand the whole task, actively think about how you're solving it, that metacognitive piece, and definitely seek out external feedback or standards. Get that reality check.
And maybe don't rely on just changing when you check in with yourself, at least for problem solving.
Yeah, the evidence isn't there, and it might even backfire slightly.
And that finding about secondary students is really interesting. It highlights motivation as potentially being a huge factor.
It really does. How do we keep teens engaged in that self-assessment process? That's a big question.
So, final thought for you, the listener, as we close this deep dive. We've talked general findings, but think, how does this apply to your specific learning? The kinds of problems you tackle?
Mm-hmm. What could be an external standard for you? Is it feedback from a mentor, comparing your work to examples, using practice quizzes?
And how can you build in more of that whole task reflection? Maybe summarizing the problem in your own words before starting, or doing a quick debrief after you finish.
Understanding how we understand.
Yeah.
It's a continuous journey, right?
Absolutely. But hopefully, this deep dive gives you some powerful tools, some research-backed ideas to navigate that journey a bit more effectively.
Reflect on these insights. Maybe dig into self-regulated learning a bit more if you're curious.
Thanks for taking this deep dive with us.